Hello friends, welcome to Grade Up. My name is Vikas and today I am going to start a very important subject of mechanical engineering, that is thermodynamics. Friends, I think you have studied thermodynamics in your BTech first year or second year, and subject is very important for various competitive exam, because every year if I talk about GATE exam, this subject, that is thermodynamics, is asked in minimum of 10 marks to maximum of 12 marks. Okay, so we can say on an average thermodynamics has a weightage of around 10 marks in GATE exam. And if I talk about other competitive exam like engineering services and SSC JEE and various PSU, this subject is important for interview as well as for numericals. Okay, so we will be starting this thermodynamics subject, and this is the first video tutorial on thermodynamics. So we can say this is the introduction part of thermodynamics, where we will see what is the weightage of thermodynamics in GATE exam, okay, by doing a weightage analysis of previous GATE questions. Okay, also we will further in the video will see what is the syllabus of thermodynamics for GATE exam or other exams. Okay, what are the reference book of thermodynamics that you can go through to clear your concepts or practice some numericals. Okay, and further we will see what is thermodynamics and how this thermodynamics study is different from heat and mass transfer study. So let's start with the video.
Subscribe to our channel and press the bell icon to never miss any update from Grade Up.
Friends, I have done a weightage analysis of thermodynamics from previous GATE questions, and what I found is from 2015 to 18, in every paper, that is in every set of thermodynamics, minimum of 8 marks and maximum of 12 marks is asked in GATE exam. So if you will see that in GATE 2015 in paper 3, it was asked when total thermodynamics, the weightage was 8 marks, in which the questions may be from thermodynamics or steady flow energy question. So from all the topics of thermodynamics, it was of total 8 marks in paper 3, and so for every paper the minimum marks is 8 and maximum mark is 12. So 8 to 12 marks from thermodynamics is asked in GATE exam every year in every set of thermodynamics or every set of GATE exam. So if you do the average, then it comes out to be 10 marks. So on an average 10 marks is the weightage of thermodynamics in GATE exam. So you can understand, as some of you may have given GATE exam, that every single marks is important to get for your score or for your rank. So 10 marks is quite a big amount, so you need to really work hard on this subject, because this is also one of the important subject that if you will go for an interview, the interviewer may ask you from this topic, that is thermodynamics. So it is very important subject, so I will be covering this subject. And if we talk about reference book for thermodynamics, then I think you must have studied P.K. Nag, and this is a very important book for concept as well as numericals. So you must have studied this book, but if you are not, then I'm suggesting you that this is one of the best book of thermodynamics. Another book is Sengels and Bose, Eunice Sengels and Michael Bose. This is a very good book if you want to go through some live example of thermodynamics, thermodynamic processes or thermodynamic topics. Then you can go through Sengels and Bose. So it is a good book. So if we go through the syllabus of thermodynamics, what is the syllabus of thermodynamics for GATE exam and some other competitive exam? Most of the syllabus is quite common. So the syllabus is basically thermodynamics system and processes. A lot of questions are on thermodynamic system and processes, mainly theory type of questions or some numericals from thermodynamic processes. So thermodynamic process, if we'll see in the further video lecture that from thermodynamic processes a lot of numerical as well as theory questions are there in the GATE exam. So this is important. Also numericals on first law of thermodynamics and some numericals from 0th law of thermodynamics are asked in GATE exam. Okay, so that we will cover in the further video lectures. Heat and work for different thermodynamic processes. Okay, so we'll go through what is the heat interaction and work interaction for different thermodynamic processes. Then we'll study what is steady flow energy equation. Okay, this is also first law of thermodynamics for open system. So every year, if I say, if from the weightage of thermodynamics point of view, one question is from steady flow energy equation, and that I am sure. Either one question from steady flow energy equation or from first law of thermodynamics. One question is there. So these two topics are important because one question is compulsory. It will come from first law of thermodynamics, either for a closed system or from this steady flow energy equation. So you have to study it very carefully. Next is second law of thermodynamics, concept of heat engine, heat pump and refrigerator. So in second law of thermodynamics, we will go through the concept of how refrigerator and heat pump work and how a heat engine works. Okay, so that we will study in second law of thermodynamics. Further, we will study what is an entropy. Okay, at least one question is from entropy in GATE exam, and availability and irreversibility. Also, there may be one question. Okay, I'm telling you this can be because I have gone through some previous GATE questions. So from that, what I have found is that there are some topics from which at least one question is there every year in the GATE exam. So I'm telling you those topics. So entropy is important, availability and irreversibility is important. Properties of pure substance. There may be one numerical based on this or a theory question. So it is important. Next is thermodynamic relation. This is mostly theoretical point of view. It is very important, where you will have to study four Maxwell equation. Okay, Joule-Thomson coefficient. There can be numerical question or theory question on Joule-Thomson coefficient, and Clausius-Clapeyron equation. Although these are the three topics, but they are very important. At least 1 marks or 2 marks type of question can come from this topic. Okay, so this was all the syllabus of thermodynamics. That is, I have written here on the basis of either on behalf of either GATE exam or other competitive exam. Okay, the syllabus is quite common, so this is the entire syllabus of thermodynamics that we will be covering in further video lectures. So this was all about thermodynamics, weightage, syllabus, and what are the reference book. Now we should understand what is thermodynamics and why do we need to study thermodynamics. Friend, I think when you were in your class 10, 12th, you have studied the law of conservation of energy principle, that energy can neither be created nor be destroyed, but is always conserved. Okay, and this was the first law of thermodynamics. This is also first law of thermodynamics. So we'll be seeing how this first law of thermodynamics can be represented by using this conservation of energy principle. Okay, also if you analyze all the processes going on around you, you will see that most of the processes are related to thermodynamics. If you take example of a tube light, suppose there is a tube light in which electrical energy is converting into electrical energy. You switch on the switch, okay, then what happens? You get light. So what is happening? Actually electrical energy is converted into light energy or further heat energy. Similarly, if you take example of a refrigerator, to run a refrigerator we need a compressor, okay, we need a condenser, we need a evaporator. Okay, so these are the components. So we give some energy in the form of an input, and what we get is the output. Okay, so we are somehow converting energy from one form to other. That is first law of thermodynamics. Also, if we see for temperature measurement of a body, we use thermometer. This is the application of 0th law of thermodynamics. Okay, so in thermodynamics, basically you will see all the processes going on around you are somehow related to thermodynamics. Maybe somehow some process are related to heat transfer, some process related to fluid mechanics. So thermodynamics is the basic of the basic science which tell you about the interaction of energy that is taking place around you. That energy interaction can be either in the form of heat or thermal energy or in the form of work. So thermodynamics, if we divide the term thermodynamics, then we get thermo means heat and dynamics mean motion, or when heat is set into the motion, then the work that we extract from the heat is all what we are going to study in thermodynamics. Okay, that we will be studying in first law as well as second law of thermodynamics. Okay, so 0th law gave the concept of thermometer, first law gave the concept of energy of conservation. Okay, that energy is conserved. Second law of thermodynamics gave the concept of refrigerator, heat engine, on which various power plants, other systems are based on heat engine. Also, heat pump is one of the application of second law of thermodynamics. Okay, so thermodynamics is a basic science of all the energy interaction taking place in the form of heat and work, and that energy interaction take place inside a system. That system approach or system analysis of energy interaction is all thermodynamics. Okay, so main components of thermodynamics are a system, and suppose we are talking we are doing an analysis at a place. Okay, that place is called a system. Okay, and also we will understand what is the external thing. Okay, if we are doing some analysis at a place, then that is called system. That fixed mass or region is called system, in which we are studying our energy interaction, and everything which is outside our system is surrounding. Okay, for example, suppose you are living in your house. Okay, so when you are inside your house, then that is all your system. Okay, you live in a house, you sleep there, you eat there. Okay, you play there, you watch TV, you do all other works. Okay, but when you are living in a house, that is your system where you spend most of your time. But when you are going outside your house, okay, then everything that is outside, then it is called surrounding. Okay, and there is something that separates our system from the surrounding, and that is called boundary. So in thermodynamics approach, we will be studying how this energy interaction take place inside the system, and what is the effect of energy interaction on the system and outside the system, that is on the surrounding. So this is all what thermodynamics study is. Okay, so in the further video lecture, we will study what is system. Okay, this was a brief introduction. Further, I will go into detail what is a system, what are types of system, and so let us for this time, let us just focus what is thermodynamics. So I hope your concept on thermodynamics is clear, that thermodynamics is a science of energy interaction and its effect on surrounding and system. Okay, so there are two things important for thermodynamics, which is system and a surrounding. Okay, and also a boundary which separate the system from the surrounding. Okay, for your house, the boundary is the walls, the ceilings, the windows, the doors, all are the boundary which are separating your house from the rest of the environment. Okay, so I hope you have understood what is a system, what is surrounding, and what is thermodynamics. Thermodynamics is the science of energy interaction in the form of heat, which ultimately lead to some work. Okay, So you must be thinking that if thermodynamics is a science of energy interaction in the form of heat, then how it is different from heat transfer? Because there is a, if you have studied mechanical engineering subject, then you must have gone through heat and mass transfer also. So why we need to study a separate subject in heat and mass transfer? And I also want to tell you that thermodynamics application are in the form of refrigeration and air conditioning, in the form of IC engine and power plant. Okay. So then how heat and mass transfer is different? So I just want to tell you that in thermodynamics we study system in thermodynamic equilibrium, in which energy changes from one equilibrium state to other equilibrium state. Okay. For example, if we take the example of a tube light, in terms of thermodynamics approach, in tube light electrical energy is converted into light energy or heat energy. Okay. So this is thermodynamic approach. But if we talk about heat and mass transfer approach, in heat transfer approach we study what is the rate of energy transfer. And if we talk about rate of energy transferred, it is always in terms of joule per second or watt. Okay, it is measured in terms of joule per second or watt. So in heat and mass transfer approach we study at what rate energy transfer take place. Okay, but in thermodynamics approach we are not interested in what is the rate of heat transfer. We are interested in at a given equilibrium state what is how much energy is transferred, or we can say that what is the energy transferred from one form to other. Okay, for example, if we take example of a refrigerator, as I told you refrigerator, then electrical energy supplied in some form is converted into the cooling effect. Okay, so we do some work and we extract some energy, and that energy is the cooling effect. Okay, so this is the thermodynamics approach. But if we talk about the heat and mass transfer approach, then we are interested in what is the heat transfer rate. Okay, or what is the cooling rate at in a given time, what is the total amount of cooling effect we can produce or extract out of a refrigerator or an air conditioner. Okay, so a heat and mass transfer analysis approach is different from thermodynamic approach in such a way that in thermodynamics we just study systems in equilibrium, and in that system equilibrium how much energy is converted into other form of energy. Okay, how energy is converted into some other form of energy. Okay, but in heat and mass transfer approach we are interested in what is the rate of heat transfer. Okay, so this is the difference between, this was introduction of thermodynamics and how thermodynamics approach is different from heat and mass transfer approach. So this was a brief introduction of why do we need to study thermodynamics, what are the application of thermodynamics. The main application of thermodynamics are in the form of refrigeration and air conditioning, which is a very important subject that is asked in GATE exam. For in every at least 1, 2 or 3 marks are from refrigeration and air conditioning, which is based on somewhat thermodynamics. Okay, so we need to clear our concept on thermodynamics so that we can go through refrigeration and air conditioning. So it is a base of RAC, that is refrigeration and air conditioning. Also from power plant there are various cycle, Rankine cycle, and in IC engine Otto cycle, diesel cycle, okay, Brayton cycle. Okay, these are all based on also a knowledge or concept on thermodynamics. So thermodynamics is the basics, like mechanics or SOM is the basic of machine design, TOM. Okay, similarly thermodynamics is the basic of refrigeration, air conditioning, power plant and IC engine, that is internal combustion engine. So we will be in further video lecture we will cover the syllabus of thermodynamics, and we will see in the next video lecture we will see what is thermodynamic approach, or what is the energy interaction in thermodynamics. Okay, that will study what is macroscopic and microscopic approach of thermodynamics, what is a system, what is surrounding, what is a process, what is a thermodynamic equilibrium. Okay, so this we will be studying in the next video lecture, and this is all for today, and thanks for listening. And if you have any query, any doubt, you can post your query or comment on GradeUp app. Till then, stay tuned to GradeUp and have a